Millions of products are reliant on computer chips, composed of semiconductors, for their complete functionality. Everything from digital products and white goods to smartphones and video games needs processing power. In the case of cars, advanced electronics are incorporated into state-of-the-art parking cameras and engine management systems. Currently, there exists a massive chip shortage. The dozens of microprocessors needed for each new car are leaving manufacturers with a sourcing problem as they vie with the consumer electronics markets to secure the supplies available, driving high industry demand in the process. It is anticipated that the present situation, which has been escalating for a number of years, will continue deep into the new calendar year, as chip production resuming at total capacity will inevitably take time. A number of factors have contributed to the current semiconductor shortage. The impact of the pandemic cannot be fully appreciated or quantified. A sharp rise in device sales had been observed as people became confined, while a lack in the need for cars has forced car manufacturers to reduce orders. This in turn forced chip makers to reorganize production. Even before coronavirus, geopolitical implications encumber the chip industry. For example, the uncertainty created by the mounting tension between the US and China in their trade relations. With their domination of chip manufacturing, Taiwan and South Korea are somewhat monopoly producers, accounting globally for 83% of processor chip production. Serving the biggest players, namely Apple and Samsung, as priority customers. Also adding to demand is the rollout of 5G infrastructure. All in all, backlogs within the semiconductor industry may mean it will take 2 years to address the current situation. It emerged that this industry was suffering prior to Christmas 2020. With the current shortage, vehicle production has consequently either slowed or been suspended by a growing list of manufacturers, including Daimler, Toyota, Ford, and Volvo among others. Jaguar Land Rover has shut factories temporarily as a result of the shortage. As perhaps the world's biggest computer chip manufacturer, Samsung cannot satisfy its customer orders. While similar challenges are being felt by Qualcomm, the company responsible for the modems and processors integral to powering so many of the leading consumer gadgets on the market. Many organizations believe implementing effective initiatives in a semiconductor circular economy is imperative to address the serious imbalance being experienced at present and to mitigate future global shortages. However, there is a question as to whether this can be realized. Shifting from disposal to recycling resources is key. Remanufacturing used system parts, qualified to the same standard as new parts, is a core initiative in the circular economy. In terms of materials, it has been estimated that 1 million smartphones contain the equivalent of 15 kilograms palladium, 34 kilograms gold, 350 kilograms silver, and 16,000 kilograms copper, while under normal circumstances ca. 3% to 4% of the daily 250,000. In terms of product recycling, companies such as ASML and Nikon are generating best practices at embedding circular economy approaches with reach and depth that will foster future success and competitiveness of the semiconductor industry. For example, ASML's Return for Reuse program seeks to reuse old equipment by producing less sophisticated chips, while ensuring progressively sustainable use of materials across processes and the value chain via refurbished products. Nikon, which also manufactures critical semiconductor lithography systems, engages proactively in the 3 rupees of reducing, recycling, and reusing. Fundamental to its approach to realize a model for a resource circulating society. This is an effective means of reducing waste. Energy-saving initiatives such as on-site projection lens replacement, for example, have also been adopted while updating the software. To open up the possibility of a sustainable future, the potential of material shortages needs greater exploration, while success will likely be driven by a circular economy agenda within the semiconductor materials industry.